So first off, we see our exponential growth differential equation, right? So we have dy over dt, so there's no dx. The independent variable on this is going to be t. But we still have that direct variation or direct proportion. It's proportional here. So if this is my differential equation, what is my general solution? Y equals what? What did we say yesterday? BC e to the k t. Now, I want us, before we even dive into this problem, I want us to look at something. If we are looking for an initial amount, so let me write this down here. For initial amount, what would t be equal to at the initial amount? What do you think? That would definitely be equal to 0. We'll pause just a second. When we're looking for initial amount, t is going to be equal to 0. Does that make sense? If we're at t time equals 0, that's the initial amount. That's the first amount that we have before anything happens. Well, let's see what happens when we plug in t equals 0. So we would have y equals c e to the k times 0. What is k times 0? What is e to the 0? So what is c times 1? So y equals c. That is always going to be true. So we can say, as a general rule, when we have this, our c is the initial amount when t equals 0. Okay? So that's just something that we want to make note of. It can be very useful for us to know that. So let's think about that along with what our problem is asking, that the population doubles every 10 years. Now, if this is the case, then when so if t equals 0 means that y is equal to c, then when t is equal to 10, what do you think y is equal to? I want you to think about that. So population doubles every 10 years. Our initial amount is c at time equals 0. So then in 10 years, what would our amount be? Think about it in your groups. What would be our y here? After 10 years, if at time equals 0, y is c. At time t equals 10, what would y be? In your groups, discuss. Now to aid you in your conversation, remember our y value is the population. The population is that output y value of this equation. So, if at time equals 0, y is equal to c, what would it be in 10 years? Population doubles. So let's say c was 5. What would it be in 10 years? 10. What if c was equal to 13? What would it be in 10 years? What if c was equal to 900? What would it be in 10 years? So what are we doing to our c? Multiplying it by 2. It's doubling. So it's not c, it is 2c. It is doubling. 2 times c. c is 5, we're doing 2 times 5. c is 13, we're doing 2 times 13. c is 900, we're doing 2 times 900. Yes?
But if c is a constant, wouldn't it just be c subscript like 4?
Okay, yes, but we're going to use 2c right now, okay? Because it helps us with what we're doing here. It's very specific in what we're doing. So, Matthew brings up a good point. Every time we have a c and we change it by multiplying or doing something like that, it changes to just a new constant. And that is true, but for the purpose of this problem in finding our value of k, we need the 2 there. And I'll show you why. So now that I know this fact, I can go ahead and say that I can set up an equation with the t10 and y equals 2c. So that would be where I have y equals c e to the kt. I now can say that that is 2c equals c e to the k times 10. And the reason why I want to do this is now when I go solving for k, what happens to my c's? Because I don't know what my c is, but I need it to go away to be able to solve for my k. And this is the only way that it will, is that when I go to solve, I divide by my c's and they cancel. And I am left with 2 equals e to the k times 10. Now I only have one variable, one unknown, my k. Before I had 2. I had a c and a k that I didn't know. But now my c's, because of this relationship, it doesn't matter what my c is. In 10 years, it's going to be doubled. And so the c amount gets canceled out, and I'm just left with that doubling amount. Yes? Well, we did that, right? We did that right here. And it just leaves us with c. And so we need to, so we had the 1 point, but we need to have another kind of fixed point on this curve that allows us to then find k. If we're not given c or given another point, we need to be able to then find it by using the relationship of doubling. Okay? Otherwise, if you're not using this, why do they give you that information? You have to use it at some place, and we're using it here. Now, how would I go about solving for k? We log both sides. So that's going to be ln of 2 equals ln of e to the 10k. What happens to the ln and the e? And I'm left with natural log of 2 equals 10k. How do I solve for k? Now it's calculator time because our answers were in decimals. So k is equal to, calculator time, pull it out, find out what natural log of 2 divided by 10 is. Now, I just want to note, you'll see problems like this frequently where it says, after a certain amount of time, things double, or it might triple or quadruple or things like that. Or after a certain amount of time, it's going to be half or a third or a fourth. They're going to do things like that, so you will not know what your initial amount C is, but you can use the relationship of doubling, halving, quadrupling, and be able to do the same process. Okay? All right, do we have a value for K? Kaden?
About 0.069.
So A? Does everybody agree with A?
Yeah.
All right, there we go. 0.069. So A. All right, any questions? Okay. Here's another problem. I want you guys to try it in your groups. Just note, they actually give you what K is. Now, if you do this right, there actually really isn't any solving you have to do. Just think about what we've talked about. All right? All right. Let's check in. Let's see. Which one do we think it is? A, B, C, D, or E? It is A. Now let's see as to y. So we have dy dx is equal to 4y. So that's a nice proportional relationship. So our general solution y equals what? So that would be our general solution. So your job is to figure out what c is. That's using the initial condition. So what could we do? Plug in y and x, solve for c. But we also saw on the previous problem this right here. What is c if our variable is equal to 0? C is the y value. We saw that right here. If we plug in 0, general, if we plug in 0, y is the c amount. If you don't remember that, you can always plug it in. It's not the end of the world. You can go 4 equals c e to the 4 times 0. But if you do, you'll just see that 4 equals c. Okay? And that's going to be true. C is going to be that amount. If x equals 0, well, then there is my c amount. Okay? So that is why we get y equals 4 e to the 4x. Okay? Any questions on that one? Okay. Go ahead and try this one. So, very first thing, it says right here, the rate of change of the population. So, rate of change of the population, that would be dp dt, that's the rate of change, is proportional to the population. Is proportional. That is just our direct variation, our direct proportionality. So we have dp dt directly proportional to the population would be k times p. That is a direct proportion. Okay? That follows exactly what we've been doing, right? So our general solution would be what? Right? So in this case, we're not using y's and x's, we're using p's and t's, but the same thing, it's the same setup. I could go through the separation of variables and do the whole thing, but we already know if it is proportional and it's in that format, that is our general solution. So you are going to use your information. I would say the first thing you want to do is determine what is C. So find C. Second, find K. Then last would be to answer the final question. Last would be to find T when P equals 500. Okay, that'd be the kind of the order that you would want to go. Okay, I want to go ahead and step away now. I want you to try it, kind of have the setup, use the given information to go kind of in that order. Okay? You have enough information there to be able to do it all. All right, so we should hopefully have kind of gotten to this point. I'm going to do the first step. Okay, so our first step, C should be equal to 300. And that's because when time equals 0, population is 300. I want to use that. Because if you remember, we have P equals C, e to the kt. The unknowns right now are C and K, our two constants. But if T is equal to 0, then I would have K times 0 and the K is taken away. It's no longer there. So I would use that fact of the point 0, 300, and I would do 300 equals C e to the K times 0. Same exact thought that we did on the previous problems. because now k is gone and I just have e to the 0. And as we've already said, what is anything to the 0 power? So therefore, c is equal to 300. And now that is a constant. That is not going to change. All right? So that one's done. C equals 300. Okay? I'm going to go ahead and again step back. See if you can find the next one, your K, if you haven't already done so. All right, are you ready for me to do the next part? Okay, so let's do finding K. Now, this one is going to be using the next set of information. At time t equals 24, population is 1,000. So I'm going to go ahead and use that. So that's 24, 1,000. That's the point I'm now going to use. So that's going to be 1,000 equals, I now know what C is, that's 300, e to the k times 24. What do I need to do to solve for this? First thing. What was that, Natalia? Divide by 300. I need to do that before I can do my natural log. I need to divide by 300. So I have 10/3, or 3.33, equals e to the 24k. Josh?
Why can't we use the point where k is 0?
I already did. I already used that.
Why can't we use it?
Because it wouldn't help me find my k. I now need to find k. Let's see about that, okay? Just so you see, Josh. So I already did, so my c is equal to 300. If I use that point again, I would get 300 equals to 300 e to the k times 0. But again, this doesn't help me find my k, because if I divide 300, I have 1 equals e to the 0. It gives me a true statement, but I still don't know what k is. So I can't use that information again. I have to use a different point. Okay? So now I can do the natural log, and I have the natural log of 10/3, or 3.33, equal to 24k. Last thing to do, divide by 24, and I know a few of you already have it. What is our k value? 0.0, should be about 501, something like that, right? Or I think I saw somebody had like 0.049 something. That's pretty close too. So that just depends on how much you're rounding. Okay? Yes.
On the because like if our answer is like
They take into account a margin of error, yes. All right. So now we know what k is. K is equal to 0.05. Isaiah?
Would we be able just to leave it at 0.05?
I would recommend doing a few more decimal places. Yeah. Just gives you, especially in all these intermediary computations, you want to use as many decimal places as possible. Try not to round it until the very end. All right, so let's just finish this up. So third, we need to find t. So that is going to be using our last bit of information. So this one was second, my second step. Now let's go ahead and do our third step, and that is going to be using the next one. It says, at what time t is population 500? So that would be the point t comma 500, where I don't know what t is. But I now know my c, and I now know my k, and I can put that in. So that's going to be 500 equals 300 e, now I know my k, 0.0501 times t. And I should be able to solve that. Okay, that's the setup. I believe I saw around and about t is about 10.21. Is that what you guys were getting? Those of you that found it? Maybe a little bit off, maybe 10.22 or something like that, but around there. So I'm going to put a little approximation squiggly equal sign there. Yes.
What do you think like the average margin of error is?
I'm not sure.
Like is that a 50th? Do you think it's like or 500 would be fine?
Probably.
Okay, yeah, because I was like, I wrote 10.197.
197, yeah, that's pretty close. That just means you, actually, I wonder what the exact answer is. Let's see. How would we, so K, we could say K is this. So let me actually plug it into Desmos with the exact values there, and I wonder what our exact answer is. Let's see. All right. If you're curious what the exact answer is, the exact answer is 10.182 or 183. That's the exact answer. And that's using, I set K equal to the natural log of 10 thirds over 24. You get that, that's 0.0501 all the way down. So this is using all the possible decimal places. And then my T for my final answer is natural log of 5/3 divided by K, which that's just using the K that I set it equal to at the beginning. And so that gives me my exact answer. So we could say the exact answer, let's go ahead and put that in. That is T equals 10 point, oh, I don't like this. Let's see. I think it was 183. 183. All right, so that's the exact answer. But again, if you got the 10.21, that is fine too. You just round it along the way. Yes. At the final answer, they want 3 decimal places, either rounded up or truncated. So they would be fine with 10.183 or 10.182. So.